Now, let's state theorem number 1 in grade 12 and its converse. Now, theorem number 1 states that if a line is drawn parallel to one side of a triangle, then this line divides the other two sides in the same ratio. Or, in an actual fact, this theorem, because I've got two triangles there, it states that if a line is drawn parallel to one side of a triangle, then it divides the other two sides or their extension, because ABC, it's extended, ABC, or these lines are extended, AC, it's extended, AB, it's extended. Even here, AB, it's extended, AC, it's extended. Therefore, theorem number 1 states that if a line is drawn parallel to one side of a triangle, if a line is drawn parallel to one side of a triangle, a line is drawn parallel to one side of a triangle, a line is drawn parallel to one side of a triangle. As I am explaining theorem number 1 using these three triangles. It states that if a line is drawn parallel to one side of a triangle, then this line, then this line, then this line, then this line divides the other two sides or their extension, or extend the other two sides, their extension, the other two sides, the extension, it divides the other, or their extension in the same proportion. What do we mean by that? We mean that if a line is drawn parallel to one side of a triangle, then it divides the other two sides in the same proportion. It means that then AD over BD is equals to AE over EC. Same thing happens in this triangle. If a line is drawn parallel to one side, of a triangle, then it divides the other two sides in the same ratio. Therefore, AD over BD is equals to AE over EC. Even in this triangle there, AD over BD, AD over BD is equals to AE over EC. If a line is drawn parallel to one side of a triangle, then it divides the other two sides in the same proportion, or their extension in the same proportion. Like that. Even this one, it divides their extension in the same proportion. It divides their extension in the same proportion. Now, it's converse. Obviously, the converse is the opposite of the theorem. And if the converse is the opposite of the theorem, it means that if a line is drawn in such a way that it divides the other two sides in the same ratio, then that line is parallel to the third side. If a line, so with its converse, it's the opposite, which means that if a line divides two sides in the same ratio, then that line is parallel to the third side. If a line divides two sides in the same ratio, this line divides these two sides in this ratio, then this line is parallel to the third side. This is the converse of theorem number 1. We are going to prove theorem number 1, but the converse, it's not examinable. You are not going to be asked to prove theorem, the converse of theorem number 1. But you are going to be asked to prove theorem number 1. Now, let us prove theorem number 1. Then we are also going to prove theorem, its converse here. But knowing exactly that we are not going to be asked to prove the converse. Proving theorem number 1, because we are proving that if a line is drawn parallel to one side of a triangle, then that line divides the other two sides in the same proportion. Now, we start by given triangle ABC, with D on AB and E on AC, such that, or given triangle ABC with D on AB and E on AC, right? And E on AC, or AB and AC produced. This simply means that given triangle ABC with D on AB and E on AC, or the or is for these two, or AB produced and AC produced. This or is for this or that, with or AB produced, AC produced. Given triangle ABC with D on AB, with D on AB, or AB produced, AC produced, like that, they are produced. Now, such that DE is parallel to BC. Given triangle ABC with D on AB and E on AC, or AB and AC produced, such that DE is parallel to BC. Now, we are proving AD over BD is equals to AE over EC. Now proof. Now we start proving. We are going to draw DC and BE and the altitudes of triangle, altitudes of triangle ADE with respect to AD and AE. There's the first altitude that we can draw with respect to AD. There's another altitude. I'm going to use a different color, which this one we're going to call K, the altitude K, which is the height. And this one also the height K, the altitude H. Draw DC and BE on the altitude of triangle ADE with respect to AD and AE. We have drawn them. But we said we must draw DC. So we're drawing DC. We are also drawing BE in our proof. Now, we proof, same proof is going to be the same there and there, but we are still going to show you how possible is that. Now, for us to prove now that, we start by saying area of triangle ADE, area of triangle ADE is equals to half ADE. So it's going to be half. We know triangle is half base times height. So the base is there. There's your altitude, which is h, your height. Therefore, it's half AD times height over the area of triangle BDE, which is equals to half the base. Obviously, you see there's your height, there's your triangle DBE, there it's its base there, because there it's its height constructed outside the triangle. Don't forget, that's where we started with in part 3, where we construct if it's obtuse there, then we construct outside. Therefore, we have our base to be dB times the height, which is that. Now, obviously, this is equals to AD over dB. Why is that? They've got the same height. Don't forget, same height. Triangles with the same height, their areas are in proportion to their bases. Now, we are also, because we are told to find AD over BD, already we do have our AD over BD using the area. Now, we need also to find the area of triangle ADE, which is that, but with respect to the other height. Therefore, obviously our base is that, there's our height there. Therefore, area of triangle ADE is equals to half. Our base is AE times our K, which is our height, over area of triangle DEC or CED, which is half. Our base, obviously, there's our height. This is an obtuse angle triangle. We construct the height outside. There's our base EC there. Therefore, the area is half base times height. So EC times K, which this is going to be equals to AE over over EC. Now, I'd love to erase one of these triangles. Now, our reason here, we're still going to have same height here. So the same height K. So we must say same height, which is K. Now, but area of triangle BDE is equals to area of triangle CED. What do we mean by that? We say the area of triangle BDE, the area of this triangle, is equals to the area of this triangle. We know why is that? Because they are between, these triangles are between same parallel lines. That's the reason why we say this triangle is equals to this triangle. This triangle is equals to this triangle. We still remember when we started with part 4 that two triangles which are having the same height and the same base, they've got the same area. Therefore, since they are between two parallel lines and they've got the same base, then it means that the two triangles are equal. Therefore, since the two triangles are equal, because this triangle and this triangle is one and the same triangle, this one, triangle ADE, area of triangle ADE. But we needed to show that this and this are the same. Since this and this are equal, therefore we know that area of triangle ADE over area of triangle BDE is equals to area of triangle ADE over area of triangle CED. Since these two are equal, because of this and this are equal, then we know that AD, therefore AD over BD is equals to AE over EC. What we have just done is that by using the areas which are proportional to the bases, so that the area of this triangle and this triangle is proportional to the base, is proportional to the base. The area of this triangle and this triangle are proportional to the bases. There. Therefore, since this triangle is equals to this triangle, it means that the area of triangle ADE over the area of triangle DBE is equals to the area of triangle ADE over the area of triangle CED. Therefore, since the two are equal, it makes these two to be equal there. The proof for this is the same as the proof for that, because theorem number 1, we've just explained that this triangle and the extension and the triangle and the extension that I've just removed is the same proof. Because even here we still do the same thing. Draw DC. Where's DC? DC. We're drawing DC there. We're still also going to draw BE. We draw BE. There's BE. And we are doing the extension, the proof for the extension. If we can be given not this triangle. If we are given this triangle and they say we must extend the lines. Now, we are also going to draw the altitudes. We are also going to draw, now we also, because we've said there, draw this and that, and the altitude of triangle ADE of triangle ADE. Therefore, the altitude I can draw, there is my altitude with respect to AD. With respect to AD, I can draw the other altitude there with respect to CE, with respect to AE, with respect to AE. Now, we've just drawn that in here. Now, they can say to us, so now we're proving area of triangle ADE, area of triangle ADE. Obviously, the base is AD. Height is H there. The height here with blue, it's K. Now, the area of triangle ADE, ADE E. There's your base, there's your height. Therefore, half AD, there's your half AD times your height, all over area of triangle BDE, area of triangle BDE. You can see BDE. There is our height, which is drawn outside, and there is our base. Therefore, that is why here it is half BD times height. Half BD times height. You can see there. That is why we are left with AD over BD, even in this triangle. The area of triangle ADE, area of triangle ADE, now obviously with respect to the base. Therefore, the base is AE. You can see half AE times K, because this triangle here, ADE, has a height where the base is AE. There, it's your AE. All over area of triangle CED, area of triangle CED, area of triangle CED. You can see the height is inside the triangle CED. The height is inside the triangle CED. Therefore, it is perpendicular to the base. That is why CE over or EC times K, because the height is K. Therefore, which is one and the same thing. They've got the same height K. Even here, these two, they've got the same height H. Now, we go straight to but area of triangle BDE is equals to area of triangle CED. Then we go straight there. The proof of this, it's also one and the same thing. Also, with this extension, the proof is still one and the same thing. We're still proving we must draw DC. DC, there we're drawing DC. There. We must also draw BE. There's your BE there. There, we've drawn. Same thing that I've just done with the two triangles. The altitude of ADE, the altitude of ADE, therefore, obviously the altitude of ADE, I'm going to be drawing that, which is parallel, which is perpendicular to that. I'm going to draw that. Obviously, this is our K with respect to AE, our height with respect to AE, same as there. Our height here with respect to AD. There's our height here with respect to AD. Now the area of triangle ADE, area of triangle ADE is equals to AD, which is the base, half AD times height. That is why we still have that there, over area of triangle BDE, area of triangle BDE. The area of this triangle here, obviously its base is BD, because the height is that. There's your height. Its base, it's BD. That is why I've got BD there, times height. Now, obviously, since they've got the same height, we're going to have AD over DB. Now, the area of triangle ADE, the area of triangle ADE, which is equals to half. The base now is this one with respect to this height. The base now is this one, which is AE, half AE times K. Half AE times K over area of triangle CED, area of triangle CED. So this triangle, its area, because obviously the height is perpendicular to the base. There's your base, which is EC, That is why it's half EC times height, which is K there, which also give AE over EC. Therefore, we go straight there. Since the areas are the same, they're between two parallel lines, then this is equals to that. Therefore, there.